offset, and tool center point control options. Note, this page shows you if there's a tryout available and how much time is left. Before we can use the dynamic work offset and tool center point control feature we just talked about, we need to know where the rotary is inside the X, Y, and Z coordinate system. This is known as the machine rotary zero point, or MRZP. The mill's three linear axes move like this: X, Y, and Z. A rotary axis mounted here will rotate about the X-axis. This is an A-axis. A rotary mounted here rotates about the Y-axis, so this is a B-axis. And a rotary mounted here will rotate about the Z-axis. This is a C-axis. Get it? X, Y, Z, A, B, C. A about X, B about Y, and C about Z. The machine rotary zero point of each axis is defined by two coordinates. In this example, the A-axis rotates about X. The center line of the A-axis is defined by Y and Z-axis coordinates. So the A-axis MRZP can be anywhere along the A-axis center line. It can be here or here. The same concept is true for the B-axis center line and the C-axis center line. The TRT-100 uses an A and C axis. Once we locate the MRZP values for the A and C axes, we store these values in machine settings. The control will use these settings along with the work offsets to correctly machine the part. Now, we've called this video series Don't Fear 5-Axis for a reason. We hear over and over again folks don't want to invest in 5-axis because it's hard, complicated, or confusing. One of the best things we can do to demystify this is to get familiar with the terminology. Now that we understand the A, B, and C axes, let's get familiar with some other terms like master and slave, fourth and fifth, tilt and rotary. You're going to hear and read these terms all over the place. And I'm here to tell you they all mean the same thing. Tilt, fourth, and master are the same thing. Slave, fifth, and rotary are the same thing. These terms come from the fact that the rotary, or fifth axis, is mounted on and moves with the tilt, or fourth axis. That's why the rotary axis is a slave to the tilt axis. So, going back to our TRT-100, our A-axis can be called the master, fourth, or tilt, and our C-axis can be called the slave, rotary, or fifth. All right, now let's get to the fun stuff. Time to install the rotary. I'm going to stone the table and make sure I don't have any high spots, and then spray it down with some rust preventative oil, and we should be ready to go. So I've got my rotary on the table and I snugged it down. I fed the cables up through the enclosure and made sure that I had a nice drape on the cables when the table was as far away as it's going to get. Now I'm going to shut down the power before I connect the rotary cables in the airline. Now, check out how easy we made setting up rotary files in the next generation control. On the rotary tab of the settings window, I have two boxes: current rotary selections and select new rotaries. This is a complete list of parameter files for every rotary product we make. Now, we're going to set up a TRT-100, so I'm going to scroll down and find those files. There I am, TRT-100 P3 ROT and TRT-100 P3 TLT, tilt and rotary. Now, the tilt axis is always the fourth axis, so I'm going to set that one up first. I scroll to that file and press enter. This brings up my table orientation window where I can tell it what axis letter it is and whether it's the fourth or the fifth axis. In this case, it's set up as an A axis. It's the fourth, which is what I want, so I press enter to select that. Then I scroll to the rotary axis file, press enter to select that one, and we can see it's set up as a C axis and a fifth axis. Again, exactly what I want. So I press enter. Now, I press emergency stop and F3 to activate the rotary files. The control will prompt me to reboot when it's done. And there we go. When the control reboots, all I need to do is go back to my rotary configuration page and press F4 to activate dynamic work offsets and tool center point control. This brings up a configuration window where I confirm that my configuration in the machine matches the image on the screen. It does, so I press enter to select and I'm all done. So I zero return the machine and it's obvious that the tilt axis is not flat. So I'm going to get my indicator out, I'm going to flatten that up, and I'll show you how to reset the home position. Okay, I've got my platter indicated nice and flat, right where I want it. I'm going to jog my indicator up and out of the way, and then I'm going to go back to my rotary setup page. I make sure that the fourth axis is highlighted, and I'm going to press Insert to set TC offset. I press Enter to accept the prompt on the screen, and it resets my tool changer offset. Now, when I zero return the axis, it's going to return back to that flat position. With the A0 set when the platter is flat, I just have to rotate the A axis up to 90 degrees and indicate the platter parallel to the X axis. I tighten everything up and my rotary table installation is complete. Now let me show you a couple of simple solutions to common problems we incorporated in the next generation control. If I have a tall rotary or fixture in the machine, I'm worried about interference with the tool changer. If I have a rotary table or a fixture plate that I need to hang off the back of the machine table, I'm worried about running into the Z-axis way covers. There's now a tab on the settings page called User Positions. Here, I can set positions for tool change, travel limits, and even the second home option if it's installed on the machine. I simply jog the machine to the position I want, scroll to the axis, and press F2 to set the position. When any of the tool change mid-position settings have a value in them and a tool change is commanded, the machine will move to the tool change mid-position first and then start the tool change sequence. Be sure to set a Z-axis tool change mid-position if you need the Z-axis to move first in your tool change mid-position sequence. The max user travel limit simply prevents the machine from traveling beyond the user-defined limit. To make any of these settings inactive, simply highlight the setting and press the origin key. In order to use the dynamic work offset and tool center point control functions, we have to tell the control where the machine rotary zero point, or MRZP, is. We have a new VPS template called MRZP Probe-a-Trunnion. All I have to do is select the number that matches the rotary model I've installed. Our setup here, we put a TRT 100, so I select 2 and press Enter. I scroll down to verify the correct model is chosen and scroll down again for the jogging instructions. I press the letter key of the axis I want to jog and press the hand jog key. Now I jog the spindle to the bore, the center of the rotary axis, and I'm ready to run the cycle. The template knows all the dimensions of the rotary model, and even if it's an AC or BC configuration. The cycle will probe the center bore of the rotary and get the X and Y coordinates for the C axis. It'll probe the platter to find its location in Z, and then retract and rotate the tilt axis to 90 and minus 90 degrees to find the center of X or Y. Just like that, it's finished, and it wrote the MRZP values for settings 300 through 305 into macro variables 10,300 to 10,305. You just need to enter the values from the variables into the corresponding setting number. Now, the control knows where the MRZP is. When I set up a part, I just find the X, Y, and Z axis work offsets as established in the CAM system, and my part will be machined correctly. So, here's a quick recap. We talked about how dynamic work offsets and tool center point control make setting up a 5-axis job as easy as setting up a 3-axis job. We looked at the features page where I can find out what control options are installed on my machine, and I can activate and deactivate a tryout period for options I haven't purchased yet. We talked about the different rotary axis configurations and how to use the rotary setup page when installing a rotary on the machine. We covered the user positions page, where I can set up tool change offset, travel limits, and the second home position. And finally, we discussed using probing cycles to find the machine rotary 0 points. Well, that's all for today's episode. Be sure to join me next time on Don't Fear 5-Axis.
Hi guys, I'm Marcus Imes. Thanks for tuning in again. I want to show you around one of our most popular new products, the desktop mill. It's our most compact and economical way to learn the Haas control and 3-axis CNC programming. We designed the desktop mill to be the next step up from the Haas control simulator as a training tool. Although the control looks like a simulator, it's actually the exact same full-featured control you'd find on any of our other machines, like the VF2 over here. I want to show you how easy it is to set up the desktop mill and use VPS conversational programming to generate some code. So you can see here I have a couple blocks of plastic on the table to work with. We mostly recommend cutting plastic or machinable wax on this machine since the material is cheap and reduces damage if a crash occurs. Or, for the ultimate in simplicity, we offer the spring-loaded pen attachment, which mounts directly in the spindle. Then, you can put a clipboard and a piece of paper on the table and use the desktop mill to draw shapes with CNC code. But today, we're going to make some chips. So, I have my 1/8 inch 3-flute end mill, and I'll tighten this in the spindle. I should mention, the spindle has a permanent female ER11 collet interface for the spindle nose, so you'll need a set of ER11 collets for each machine. Now, I'll tighten my tool in the spindle. It's a small tool, so don't over-tighten it. Next, we need to give the machine some Z geometry. So, we'll set our Z-axis offset to the top of the stock to establish my Z height. I have a piece of paper here we'll use as a shim to pinch between the tool and the workpiece. Now that I've made contact between the tool and my workpiece, I'll use this as my work offset for my tool. Now, I'm going to set my work offset. I'm going to hand jog the spindle to where I want to set X0, Y0, and then set my G54 work offset. So let's do that. Move up Z a little bit. And I'm just going to eyeball this, but if you wanted to be more accurate, you could use an edge finder as well. So I'm going to set my X0, Y0 where I'm at right now. I'll go over to my offset page. From the offset, I'll hit F4. And in this case, looks like we already have some numbers in G54, G55, so I'm going to use work offset G56. I'll push part 0 set for X and again for Y. And I'm going to leave Z blank, although on most of our machines you would set a Z work offset. Here, all of my Z geometry comes from my tool, since there's no tool changer on this machine. Now that I have my X, Y, and Z established, let's go to VPS and make a short program. You can find VPS under the Edit button, then tab up to the top and over to VPS, and then go down to the VPS, and we'll go over. As you can see here, you have a few different shapes we can easily make, like bosses, pockets, drill patterns, but today I think we'll do a little engraving. So let's see what it takes to operate one of the VPS templates. These are all composed in a very similar manner, and basically you're just answering questions from top to bottom. We have useful pictures that help determine what inputs we're looking for, and we have some help text down here. So the first thing it's asking for is our work offset. By default it chooses G54, but if you remember, I set G56. So I'm going to enter 56 and enter button, and now we're using offset G56. Next, it's asking for a tool number. I can tell we are currently using tool 2 from the offset table, or from the memory screen, it also tells me tool 2 is currently active. I'm going to leave that alone since we don't have a tool changer, so 2 is a good number. Now it's asking for my spindle speed. How fast do we want the cutter to turn? I have a valid range of 50 to 24,000, so quite a bit of range in there. I'm going to choose 5,000 RPM just from my experience, and I know that that won't be too fast for this machine. Since we don't have coolant, I don't want to melt the plastic, so I'm going to select 5,000 and press enter. Next, I need to give it a feed rate. How fast do we want to move? Well, how do we calculate that? Since I selected 5,000 RPM, and I know my end mill has 3 flutes, and I know a good chip load for this plastic material is 2 thousandths per flute, I take 15,000 times 0.002, which would give me 30 inch per minute. So I'm going to enter 30 with a decimal because this one requires a decimal. Next, M8 is asking coolant or no coolant. This is a code all new machinists will learn very early on. And this is one way that VPS reinforces codes where applicable. So if you're choosing a canned cycle or like coolant on, coolant off, we're going to reinforce that with the actual M or G code in the template. In this case, we don't have coolant, so I'm going to enter 0. Now it's saying, where do I want to start? Since I positioned my G56X0 at the position that I want to start engraving, I'm going to leave this one as 0. But I am going to move Y up about 100 thousandths to get us off the center line of the part. So I'm going to enter 0.1. Now here is my rapid plane. The rapid plane is where the tool changes from G0 rapid approach to a G1 feed move. The default we have in there is 100 thousandths of an inch. I'm going to leave that alone because that's a pretty industry standard number. Now it's asking for my Z depth. How deep do I want to cut? I know that this plastic top, the red plastic on the top of this part, is 50 thousandths deep. So I'm going to say give it a value of maybe 70 thousandths, so we cut down below into the white. Now we can do either text or serial number or a specific number if we wanted to do that. In this case, I'm going to leave it 0 to select text. And we could, it's asking how high do I want it. A ½ inch looks good to me. And do I want it on an angle? In this case, no, I'm going to go straight across, but you could also do it at any angle around the circle. And now at the bottom, what do we want to engrave? How about Haas CNC? And that's the last line of this template. So from here, we can do a couple things with it. If you notice up here, we have generate code with F4. So we can copy it to the clipboard if we wanted to paste this into a program. I can output it to MDI, or I can create a new program with it if I don't already have one established. In this case, I'm actually going to use the fourth option, which is just pushing cycle start, and that will run the template directly from this page. But before I do that, I'm going to move my machine away from the stock a little bit. In case I entered any bad numbers, I want some time to push stop. So let's do that. So first thing I'm going to do is move Z away from the table a little bit. Just in case I got anything wrong, this will give me some time to realize that and stop it before I crash anything. So I'll go back to my VPS template. I'm going to change my rapid down to 5%, and I'll hit cycle start. Once I'm confident it's moving in the right direction, I can change that rapid override to a higher value. Now since the desktop mill doesn't have a tool changer, the first thing it's going to do is move to the back corner to a safe position and ask me if the right tool is loaded in the spindle. This way you can make a program with multiple tools even without a tool changer. But since we already have the tool in the spindle, per the message on the screen, I'm going to push the letter K to continue. And now I'm going to change the rapid override down a little slower. Now that we're moving in the right direction, it looks like. Speed it up a little bit. And just to make sure I got all my heights correct, I'm going to stop at just before it gets to the material and look at my distance to go screen. So I'm going to press position and then tab over to distance to go. I see I have 49 thousandths, which looks about right. If that number was drastically different, that's your first warning that something is wrong and you should stop and double check everything you've done. Now that I've verified my distance to go is good, I'll press cycle start and continue. So, I think you can see why there's a lot of excitement around the desktop mill. It takes a full-size machine's capabilities and shrinks it down to about the size of a mini fridge, but still allows hands-on setup, programming, and troubleshooting experience which directly translate to our full-size machines. Check out HaasCNC.com to get a custom quote on your own desktop mill with our build and price tool today. Thanks for joining us.